So this is an example of two hard questions from section 2.7. This one's hard because it might be hard for people to think about the common denominator. So like on the right hand side, it's got x times x plus 4. So when you're thinking about the common denominator, if you look here, it's got an x plus 4, and if you look here, it's got an x times x plus 4. So you're going to multiply the entire equation by x times x plus 4. So when you multiply the x times x plus 4 by the 2, there's actually nothing that will cancel, and so you end up with 2x times x plus 4, which is 2x squared plus 8x. When you multiply the x plus 4 times the x plus 4, this x plus 4 and this x plus 4 will cancel, and you'll end up with minus 3 times x. And on this step, when you multiply the x times x plus 4 by the 12 over x times x plus 4, everything cancels, and you end up with 12. So now you also have a hard problem because this is a quadratic. If you look right here, that's squared, and as soon as you see something squared, you have to get it equal to 0. So this is 2x squared plus 5x minus 12 equals 0, at which point you need to factor or use the quadratic equation. And this is a factoring by guess and check method, I think. 2x times x. I need the outside and inside terms to add to 5. And so if I make this 4 and this 3 and the 4 positive and the 3 negative, I end up with two roots, one positive 3/2 and one negative 4. So this was hard because it had a hard common denominator, and it was also hard because it had factoring. The second problem doesn't actually look that hard, but it turns out that way, because when you multiply this problem by the common denominator, x minus 1, in the first part, the x minus 1's cancel and you get 2. In the second part, the x minus 1 distributes, so you get x squared minus x. And in the third part, it distributes across the 5, so it's 5x minus 5. So now, looking right here, you're like, oh, this is a hard problem because I've got a squared, it's a quadratic question. So I move everything over to the left and rearrange, so I end up with x squared. I minus 5x from both sides, so I get minus 6x. And I also add 5 to both sides, so I get 7. And it really sort of feels like it wants to be factorable, but if I try factoring, if I get if I make the 7 and the 1 both, so if I go 1 times 7 is 7, and I make them both negative, I end up with negative 8 for the middle term. And if I make the 1 positive, so I can get negative 6, then the 7's not negative, and so I'm sort of stuck on this question. So this one I have to solve either by completing the square or by using the quadratic equation. And so since factoring didn't work for me, I'm going to do this one by completing the square. So I end up with x squared minus 6x, move the 7 over, add half of 6 is 3, squared is 9 to both sides. I get x minus 3 squared is equal to 2, so x is equal to 3 plus or minus the square root of 2. So this one's hard because you had to complete the square. That was about it. And you could have alternatively, instead of completing the square, gone straight from this step to the quadratic equation. X equals 6 plus or minus the square root of 36 minus 4 times 7 all over 2. And if you simplified that, the 6 divided by 2, that becomes the 3 right here. So this 6 divided by 2 becomes this 3. And this is the square root of 8 divided by 2. And that becomes 2 square root 2 divided by 2, and the 2's cancel. And so this part right here, the square root of 8 divided by 2, just becomes the square root of 2. Hard because you had to use a quadratic equation, or hard because you had to complete the square?